You can unmute your mic if you want. You can explain if you remember what we have discussed in our previous session. LUTs, exactly. So, like, what is present inside an FPGA? What makes our FPGA configurable, right? So, the major reason for the configurability of FPGA that we have discussed in our previous session, right? Exactly. What is full form of LUT? Full form of LUT? Lookup tables. Exactly. Yeah. So where exactly these lookup tables are present? Inside CLBs. CLBs are nothing but clocking blocks, or you can also say them as logic elements, right? Yeah. So CLBs contain these LUTs as well as flip-flops for uh, implementing your sequential circuits. And if you want to implement a simple combinational circuit, you just need a simple LUT, right? Exactly, correct. So that was our discussion in our previous session where we have discussed about what is our lookup table and what is exactly which is present inside an FPGA, what is a block. We haven't started yet regarding the block RAM and all. And we have seen the number of functions or Boolean functions which we can implement using a two input LUT, three input LUT, and what do you mean by two input LUT, three input LUT, and what is the architecture of this uh, FPGA where we are going to have programmable interconnects, IO blocks, and all things. And we have also seen how this LUT is going to work and what is the configurability that makes this LUT working, right? And yeah, this is what we have seen and what is exactly this CLB is going to contain and what are these lookup tables and this and all things we have discussed in our previous session, right? So yeah, and we have missed one small particular concept which is known as parallel processing, right? So during our discussions, we have seen that FPGAs are basically have the ability of doing parallel processing. Okay, now how this FPGAs achieve this parallel processing thing is with the help of this right? With the help of this particular CLBs. Sorry, with the help of this particular, yeah, I mean this CLBs, right? So we have this multiple CLBs, and if we want to implement a particular Boolean function, the tool is going to divide all our logic into multiple CLBs, and it is going to achieve this parallel processing, right? All the CLBs will be working parallelly. For implementing a complex Boolean function, your CLBs will divide those work and they are going to run in parallel. Okay, using this particular concept, we can achieve parallelism. So that's why FPGAs are very high speed, and you can achieve parallel processing using this FPGAs, right? Yeah. So that is what we have discussed in our previous sessions, and this was the notes about this particular thing. Yeah. I'm not able to get some of this. So you can also rewatch the recordings which we have posted in the group. Okay, so that this session time is not wasted. Okay, we have limited amount of time and limited amount of sessions. So I recommend you please go through the recordings which we have uploaded in the YouTube so that we can save the time. And if you still not able to understand what is that, you can always uh, yes. So let us start this particular session. Is it okay, Abhijit? Yes. So let us start this particular session. So in this particular session, we are going to discuss FPGAs based on the configuration technology, right? So basically, this particular FPGAs are divided into three types. One is SRAM based FPGAs, and another is flash based FPGAs, and followed by anti-fuse based FPGAs, right? So let us try to understand what do you mean by these categories. Okay. So the very first one is SRAM based FPGAs, right? So basically, in the case of your SRAM based FPGAs, whatever the configuration data that will be stored in the SRAM cells. Now, what do you mean by configuration data? Configuration data is nothing but what LUT should be contained, what are the contents of that particular LUT, which CLB should be activated, and what should be the connections. Everything that and all is nothing but my configuration data. Okay, how that configuration data is generated and where it is stored, that we will discuss. Okay, but this particular configuration data is basically stored in SRAM cells if you are working with an SRAM based FPGA. Now SRAM is basically volatile. Now what do you mean by volatile? What is a volatile memory? Anyone knows what do you mean by volatile memory? Lost when reset or power off. Okay, any other answers? data will be erased once power is off. Exactly. So basically, whatever the data you have stored inside that particular hardware, if you when it is powered on, okay, when the power is on, so that particular data will be erased when you are turning off the power, right? And when you turn it on again, the data which you have stored will be erased. That is nothing but your volatile memory. Okay. What do you mean by non-volatile? So whatever the data which you have stored inside your hardware will not be removed if you turned off the power also. Like let's say suppose if you have a hardware, okay. So let's say if you have a memory like this, and inside this memory you have stored some data, right? And you have turned on the power, and without power you cannot store the data. Okay, it may be volatile or it may be non-volatile. Without a power you cannot store the data. By applying the power you have stored some particular data, and if you have removed this particular data, this data will also be erased. If you have removed this power, then this particular data will also be erased. That is nothing but my volatile. Okay. And coming to my non-volatile, when you have applied your power and if you have written some data into this memory, and if you remove this power also, this data will not be erased. Okay. That is nothing but my non-volatile. So that is the difference between your volatile and non-volatile memory. Any examples of volatile memory? Have you seen anywhere in your real life? Volatile memory anywhere? Exactly. Volatile is RAM. So the data you can store it temporarily inside your RAM, right? And any other examples of your volatile memory? Exactly, catchy. Yeah. And any other examples of non-volatile memory? Have you seen anywhere any examples of non-volatile memory? Hard disk, right? So whatever the files or whatever the programs or whatever the software which you are going to have, that will be stored inside your hard disk, right? Exactly. Yeah. Now, so basically, this SRAM based FPGAs are volatile in nature, and FPGA will loses its configuration when the power is turned off. Okay. Now, let's say if you are going to have an SRAM based FPGA, where let's say if you have programmed this FPGA to work as a AHB controller. Okay. You have programmed this particular FPGA to work as a AHB controller. Now, you have turned on the power and you have configured this FPGA to work as a AHP controller. And if you are removing this power, whatever the configuration file you have loaded in this FPGA or whatever the FPGA working as a AHP controller, that functionality will be removed and it will be again a normal hardware with no functionality. Okay, so that is nothing but my volatile, and examples of are Xilinx Artix, Kintex and Vertex, and Intel you have Cyclone and Stratix. And it also depends upon more specifications, like there will you need to search it, and you need to first of all see the specifications. Okay, and these are the companies, they offer SRAM based FPGAs also, right? And these are basically used for what to say, some testing purpose and or some just for lab purpose, right? So they cannot be used in real time application. If you use them, then whatever the configuration you have loaded, that will be removed immediately if you are removing the power, right? Now, you cannot simply rely on this alone, right? Now, next comes your flash based FPGAs, where your configuration data which you have stored inside that chip will not be erased. Okay, so you have microchip and lattice, and Xilinx also we have flash based FPGAs. Okay, and Intel also we have. Okay, so you need to check for the exact specification, like what is the exact board you are working with. There you can see whether it is a flash based FPGA or Intel based FPGA, right? Yes. Now, next is yeah. So this was about your volatile memory and non-volatile memory and SRAM based and flash based and antifuse based. Yes. So is it clear for everyone? Any doubts or any queries? Please let me know in the chat box. And what about others? What is non-semiconductor based memories? Like your HDDs or CDs or DVDs. Okay, those are all non-semiconductor based memories. Uh, which part I need to repeat? And what about others? Is this particular thing, is it clear? SRAM based FPGAs and flash based FPGAs, is it clear? Shall we move forward? Okay. Okay. Flash based FPGAs, if you are going to store your configuration data inside your flash based FPGAs, that data will not be removed even if you remove the power supply also, because it's a non volatile memory. Okay. Yes. Now, so let us start our discussion about what are the major FPGA companies which you need. And I get this queries. Can you please repeat SRAM versus flash based? Yeah, basically, in the case of your SRAM based FPGA, if you are working with SRAM based FPGAs, if you have stored some configuration data inside this FPGA, when there is a power, when there is a power, and if you remove this power, the data which you have stored inside this SRAM based FPGAs will also be erased. Whereas in the case of your flash based FPGAs, whenever you have applied the power and if you have stored any configuration data into this FPGA, and if you are removing the power also, this configuration data will not be removed. It will stay. And when you repower it, then also the old configuration file which you have stored inside this FPGA will be used. Is it clear, Amit? So there are techniques where you can also remove that data which is stored in flash. So there are techniques like we can use some tool. Basically, I will show you using whitest tool. We can remove the data which has been stored in the flash based. Okay, that is basically stored in the memory. We can remove. Not that we cannot remove. We can also remove that particular data which has been stored in flash. Right. Yeah. So these are the two technologies you can see nowadays. Okay. Yes. So next comes this particular major FPGA companies which we are going to use, right? So we have AMD Xilinx and Intel based FPGAs, which is Altera and Microchip and Lattice Semiconductor, right? So these are the different vendors which we have. And I get a lot of questions like what and all, why we should learn all this theory. Just we will start with the coding and we will implement on the FPGA. But if you don't know what is exactly which is present inside an FPGA, if you don't know what is volatile and if you don't know what is non-volatile, when you join any particular company and if you have given any specifications and if you cannot read that particular specifications, then you cannot move forward, right? So you need to have a good understanding about all each and every simple things, right? Yeah. Now, so let us start about this particular AMD Xilinx based FPGAs, right? So these are basically market leader and they are strong in high performance and SoC based FPGAs. Now, what do you mean by SoC based FPGAs? That we are going to discuss in our next sessions, okay? And it is widely used in the industry and academia, okay? And they have both SRAM based configurations as well as flash based also, okay? And they basically have 3 input, 4 input, 5 input, and 6 input LUT architecture and advanced routing fabric. And they are also going to have something known as DSP and BRAM resources. Now, in our previous session, when we were discussing about this FPGA internal architecture, we have seen something known as CLBs, right? So, like this, we have seen some CLBs. In our FPGA, apart from the CLB, we will have something known as BRAM. Okay. So what is full form of RAM? I think okay. Am I too fast? Is my pace too fast? Okay. I think it was very slow. Okay, okay. I will go a little bit slowly only. No issue. Okay. So RAM stands for basically. Okay, okay, okay. Great, great. Yeah. So basically, RAM stands for random access memory, right? Now, what do you mean by block RAM is basically inside your FPGA chip only, a particular memory has been allocated, but it is very less memory, less amount of memory, less number of locations will be present. Okay. Inside your FPGA only, you are going to have on chip only, you are going to have something known as BRAM, which is also known as on chip memory. Okay. So because we are having the memory on the chip, right? So that's why it is also known as on chip memory. So you can also use this memory, like if you want to. Yeah, RAM is nothing but random access memory. It's a type of memory. Now, why we are calling it as BRAM or block RAM? Because it is present on the chip. Okay, it is a name which has been given to that particular memory because it is present as a block. Exactly. We will come to that particular points. What is URAM, everything. But these are the fundamental things. Even a small low cost FPGA is also going to have BRAM, which is available with it, right? So BRAM basically it depends upon the FPGA configuration. How many BRAMs will be present? How many LUTs will be present? Okay, it depends upon the configuration which you are going to have. I think I'm going in a slow pace only now. Others, please let me know. Am I going in a slow pace only, right? Yes, yes. Yeah, yes. And this BRAM is also volatile in nature. Very good. So this BRAM is also volatile in nature. Okay. Yes. So we will see one project related to this BRAM also, like how we are going to use this BRAM and why we use this particular BRAM and what is external memory, what is internal memory, okay, what is on-chip memory. This BRAM is an on-chip memory because on the FPGA chip only internally with the CLBs we are going to have this BRAM, okay, and we have something known as external memory, okay. So the important point to be noted over here is BRAMs have very less memory locations. It has very less memory locations, right? And but why we are using this BRAM? Because for accessing the data very quickly, it's like your cache. Okay. What do you mean by cache or cache, whatever your pronunciation may be? What is the use of that particular thing? Why we use it? Anyone knows? Temporary memory. Okay. Why we need to have a temporary memory? Data in a to fetch data faster, exactly. So here also if we want to fetch our data in a less time, we are going to use this BRAM. Okay. Let me give you one simple example. Let's say if you are working with some image processing project, or let me show you. Let's say if I'm working with some image processing project, right? And I have written some code, and that particular code has been written into the CLBs. And this CLB need to, okay. So what is going to happen is whatever the image you are going to take, that will be converted into binary format. Okay. So let's say if you want to perform any image processing techniques like erosion or binary to gray or gray to I mean color to gray or gray to color or something, right? So we have different type of image processing techniques, right? So image enhancement, you can, let's say if you want to perform some enhancement. Okay, I'm not going to this particular technique, like what do you mean by image enhancement or something, right? Now, let's say if I'm writing a code of image enhancement, basically that particular code is present inside your CLB. Okay. And for performing that particular image enhancement, the CLB needs to have get the data. What is that particular data? That is nothing but my image that has been converted into binary format. Now, where is this binary data which will be present? If it is present inside your BRAM, then it is going to take very less time to take this data from data into CLB and to process that particular data and to return that particular data into the VRAM. Okay, so this is where you can have one application of VRAM where you can able to fetch the data within a less time and you can store the data into the VRAM within the less time. Okay, is it clear? The example, is it clear? No, SRAM and VRAM are different. VRAM is block memory, which is present inside the FPGA itself. Exactly. It is going to act as a cache. And is the example clear for everyone? Yes or no? Please let me know in the chat box. Great. Yeah. Okay. Exactly. Correct. Now, so that is BRAM. And nowadays, inside your FPGAs, you have something known as DSP blocks also. DSP stands for digital signal processing blocks. Okay. So you also have this particular DSP blocks for performing signal processing techniques, right? BRAM shared between multiple CLBs. Exactly. CLBs will share this BRAMs. There will be multiple number of CLBs and BRAMs according to the board or the FPGA configuration you are going to take. Okay. I will show you like how to choose your FPGA, how to read your schematics, how to read your specifications. Uh, we haven't yet started about off-chip memory. We are still talking about on-chip memory. Okay, so don't get confused between SRAM and VRAM. About the off-chip memory, it is present in the next slides. Okay, when we are going to take a case study also. Like we are going to take a project, and for that particular project, how exactly you are going to store the data, where exactly configuration data is stored, where your actual data is stored, or where the input vectors for your design is stored. Everything we are going to take. Which is off-chip memory? Do you mean SRAM is off-chip memory? Yes, exactly. Okay, I will show you one picture then. You may want. So this is the official. I think my screen is visible, right? Once, please confirm me. Yeah. So this is the official website where you can visit. Okay, Artix. I'm basically displaying the Artix A7 board FPGA, which is an SoC. Now, this particular SoC which I am talking about, this is nothing but my FPGA, right? Artix A7. Now, inside this FPGA only, you are going to have your BRAM. Okay. I don't know where exactly your SRAM and flash memory is present because I need to see the configuration schematics of this, right? So this picture is not clear. Let's say this particular chip is a memory. Okay, this is said to be an off-chip memory. It may be a SRAM or it may be a flash memory. Okay, what I was talking is BRAM will be present inside your FPGA only. This is nothing but your FPGA. Okay. This chip, I cannot see it clearly. It may be a SRAM or it may be a flash. Okay. This is nothing but my off chip memory. This is the difference between on chip memory and off chip memory. Now is it clear? HDD, SDD, off chip memory. FPGA, we are talking about FPGA. HDD and SDD, those are huge storage memories. We are not going to store that much of memory or data in our FPGA, right? So we are either going to have simple SRAM or DRAM. We are not going to store GBs of data. Okay. So the thing is very simple. We have two type of memories. One is on-chip memory and another is off-chip memory. We are simply talking about on-chip memory, which is known as BRAM. Okay, which is a small memory unit which is present within the FPGA. Okay, what it stores that we are going to see later. BRAM is always on-chip. That's why it is known as block. That's why it is known as block memory. Okay. I just mean SRAM is usually on chip also when we consider laptop. Yeah, you might see. So shall we move forward? Is it clear? I hope it is clear, right? So don't get confused with this particular terminologies and don't go into the things. We will have some scenarios and we will have some case studies like how the data is stored and where the data is stored and how we are using where we are using this BRAMs. This particular session, we are just understanding the terminologies, right? Okay. So let us move forward. Let me share my screen. So I was talking about this Xilinx. What happened? It has got stuck. 1 minute. Yeah. So I was talking about this Xilinx based FPGAs where we have, yeah. So where we have major families like Spartan series. Okay. So Spartan is also a part of Xilinx based and Artix series. Just now we have seen one picture, right? So that is Artix. And we have also Kintex. Okay. And we have also Vertex, okay, ultra scale plus, and Zinc SoCs, okay, where we have FPGA plus processor. What is this FPGA plus processor that we are going to see? Okay, so you need to there are so many vendors, and you need to have and why I'm showing this particular things is you will get some familiarity, like what is this, you will get some user to you will get user to this particular names, right? So we have Spartan, you have Artix, and you have Kintex and Vertex and Zinc. So this will all come under your Xilinx. Okay. So Spartan is basically low cost and older architecture, and it is used for simple education and simple designs. And Artix is low power, mid range, and it is used for learning, embedded systems, and control applications. Why it is used for embedded applications, that we will discuss in our later sessions when we are going to discuss about something known as SOC architecture. Okay, so where you will get a clear idea about what I am talking about, right? Now, and I have also something known as Kintex, which is very high performance, and it has DSP blocks which is present inside it, and it can be used for serial processing and communications. And we have something known as Vertex, which is also a high performance, and it is also used in data centers, 5Gs, and AI acceleration. And we have something known as zinc based FPGAs. Okay, this is what we are focusing more upon more, because we have this particular board with us. We are going to discuss this zinc architecture more in detail. Okay, where we can use it in for embedded Linux and automotive and robotics also. Okay, so it also supports RTL, IP integrated, and HLS. HLS basically stands for high level synthesis, where you are going to convert your C code into an RTL code. Okay. That is nothing but my high level synthesis. Okay. So the main agenda of this particular session is to get you familiar with this particular terminologies. Like if you don't know what is current, what is this names also, it is very difficult to understand, right? So this particular session, our main aim was to understand what are the different memory architectures we have, like SRAM based and flash based, and what do you mean by on chip memory and what do you mean by off chip memory, and what are the major families which we are going to have. We have basically divided the FPGAs into two types. One is Xilinx and another is Intel based FPGAs. And in the Xilinx based FPGAs, these are the different type of families which we have inside our FPGAs, right? And in our next session, we are going to start with something known as Intel based FPGAs, where we are going to see different Intel based FPGAs and different families which are present inside our Intel based FPGAs. And after that, which we are going to see is how to read a part number. We are going to have something known as a part number for for every FPGA. We are going to have some part number as we have Aadhaar card, right? So like that only, each and every FPGA family is going to have something known as part number. So using this part number, we are going to see what is this part number and everything, right? Yeah. So this is about this particular session. So if you have any doubts or any other queries you wanted to discuss with me, you can stay and discuss, or else you can leave the session. Okay. Thank you. I hope you have got some valuable information from this particular session, right? Yeah. Thank you. Every board, yes, exactly. We have latency. We will also work on any project implemented in Xilinx Vivado. We will try. Definitely one simple course will be shown, but I cannot promise on project because we have a limited amount of time.